which is this stage 1 here. I have successfully identified which of the beam elements are critical. Like for member shear force, we realized that these 2 beams are critical, and member core rotations, basically these shear walls, and also maybe I will consider this strengthening of this column as well. All right, so now I complete the stage 1 already. Let us move on now to stage 2. Okay, so once I know these few members, we can go back to the building modeling. I go to apply the retrofitting to this building. All right, so I click building modeling, go back to our building model facilities. Okay, so just now, as what I already find out is, realize is this walls is quite weak, and also this column maybe I need to think about to do some strengthening. So to do that is, for this concrete shear wall, there's a lot of options. You can, for this building, you can decide to maybe put another wall here, because this shear wall looks like very thin, very slender. But in this wall here, I can show you is we can put some maybe intervention, like for instance, we can apply FRP wrapping in this shear walls, in this concrete wall. We can, for seismic, we already got defined a list of the company, the FRP system. So you can use maybe like Sika, MAPE, or any system that is convenient for you. In this case, I will choose maybe Sika. Based on the first selection, I choose this particular Sika wrap systems. Then I will choose maybe a strengthening, let's say 2 layers. All right, and then it's the externals. Okay, then I will click OK. So you notice that is once you have already input this FRP here, this particular column here or wall here is highlighted with shaded color, indicate it's already applied with FRP. All right. So I want to show you again some other feature, like for instance, concrete jacketing of this column. All right. So maybe just now, as I mentioned just now, this value here are very close to 1, exceeding 1. So for safety reason, I want to concrete jacket to strengthening these columns. So what I'm going to do is I'm going to apply the jacketed rectangular section to this column. All right. So in this column here is C3. So we select this function, insert jacket rectangular column. Okay. So you notice that is once I insert this value, this icon, this layout will come out. So it's similar to insert to origin to any column. Only different is under the view and modified geometry. There's a 2 section. Distinguished by 2 different color. One is the light blue. One is much more darker blue. The light blue, this color representing the existing section. The darker blue here representing our new concrete, which is our jacketed concrete. All right. So in this example here, what I'm going to do is I'm going to do a jacketed concrete of 100 mm, the whole perimeter of this column. All right. In this column here is 250 by 750. So I change this dimension, maybe 200. Maybe I change it become 950. All right. And then the original one is the original column for C3 is 750. Okay. And the width in this case here, the original is 250. So I strengthening 100 mm for both sides. So it's become 240. And the original column size is 250. All right. So this is the strengthening the jacket column dimensions. And again, is we have to define the foundation. I think this foundation is 1 meter below the finished floor levels. So once we're happy that, we go to the next one is the external rebars. So external rebars, you have to decide or do some basic design about what is the rebar size. So in this example here, I will use maybe the easiest way, use the default values. Okay, default, I use the corner 420 size of the bars, and the top and bottom I use 16, and the side I use left and right side I use 16 as well. For shear, I using this external jacket column, I use maybe 10. and spacing is 15 centimeter. All right. And for the internal one, we have to select the original one, because the original, if you look into our presentation slide, is for number 18. All right. And the top bottom, there's a rebar of two number of 14. If you go back to the original drawings. And our spacing is basically is 8 mm by 220 centimeter actually. All right. So the rest of the value are the same. The rest of the setting are similar. Oh yes, another additional thing is material set. You can see that there's an internal. Internal will be our existing, and the jacket will be our new material. All right. So in this case, if you want, you can select the new material as a maybe fiber reinforced concrete as a new strengthening of this section. But in this case, I use the default values. The rest of the setting is the same, the FRP wrapping and advanced material. So, all right. So once we're happy with the setting, we can go back to the view and modify. So we can insert our jacket column directly on top of it. So in this case here, we can select this corner because we select the existing column, the insertion point here to insert our column. So we insert here. So straight away you can see that we insert our jacketed column here directly. And another thing you notice that is every time we insert a new member, the concrete slab will be deleted. So you might need to insert back the concrete slab later on. Okay. So another thing is maybe we can try to consider maybe C1. Oh, sorry. Let me delete this member. All right. Maybe let us try to also consider C1 for strengthening as well. Maybe concrete jacketing for C1. Okay. Let's go back to jacketing, rectangular columns. In this case here, maybe C1 is 400 by 400. The section size we can choose. So in this case here will be 400 by 400, same strengthening of 100 mm thickness for the whole parameters. So it becomes 600. Okay. So the original one, this one is 400. You can choose from here. The original one is 400 for C1. And this one will be 600. Oops. So it is 600 here. All right. So it looks like this shape of the columns that you want to do the jacketing. The rest of the detail is the same. Reinforcement detail, let's keep it the same as well. Okay, we don't want to change much. And then for the internal, I think internal here, there's no any sidebars. There's only four numbers of 18 mm size rebar. The size of stirrup are all the same. Okay, once we're happy with that, go to the geometry. Then we insert. I can insert this. I can select this point as an insertion point. And then I insert here. So straight away insert the column for us. Okay, and then for this particular column here, maybe for C2, maybe I try to apply FRP like what we do for the shear wall, for the concrete walls. I select FRP wrapping, select from the list. In this case, I use maybe other manufacturer. I use Mate. I can use maybe what kind of system you prefer. I use this particular system. I can select maybe in this particular case, I provide 3 layers and select external. All right. So you can see that is all these technical data are already predefined for you, are based on the manufacturer catalogs. So you no need to define these values. If you want, you can select user define. User define, if let's say you got some type of FRP, it's not in the list here, you can user define it yourself. So it's quite easy. So in this case, I choose this one, 3 layer, external, I click OK. So once you click OK, you see this button here show, this button already displays the FRP. So FRP already applied to this column. Okay. So once we're doing that, maybe we can try to insert back the slab. Okay, insert back the slab. Okay. So once we're doing that, the next step what I'm going to do is I try to do the strengthening for the beam, which is this beam here, this beam and this beam, retrofitting the beam. The beam, I'm going to use this function, insert jacket beam. Click OK. All right. Similarly, we have to define this. The original size of the beam itself is basically 250 by 500 actually. And then in this case here, we're going to do the same thing as the column. We enlarge 100 mm, the whole parameter, the cross sections. So the width will become 450. All right. So in this case here, the top there, I assume that maybe we increase to 100. Oops, 100 here. And then this one I will increase to 700. Okay. So this is the size of the jacketed beam looks like. And let me go to the top here. These are the dimensions. And the reinforcement rebar, maybe let us try to apply the same thing. Okay, I will use all the default values, keep it simple. All right, but you can feel free, after you do the design, you can define your rebar size from here. And the spacing, I provide a much more closer one, this one here. Then the internal you might need to change to our original one. The original one is actually 3. The lower is 2, is 14. Let me change back here. And the top is 3, 14. There's no side, this is correct. And the lower one is 4. Let me increase 1. The top is 14. 2 number of 14. No side. And the rest is 2 number of 14 and 3 number of 14. Again, there's no side here. All right. For the stirrups, is actually 20 centimeter, not 30 centimeter. Let me change back. This is the original one. All right. So we done everything already. If you're happy with that, we can insert the beam. So in this beam here, we can apply the insertion point similar to what we done just now. We can in this case, I think the easier we done from starting from the middle. So what I do is start from the middle of this column. I go downwards here, apply the insertion of this beam. This is how I apply the beam. In this example, we can start from here as well. Can start with any corners you want, like here. Maybe let me select this point to object and to drawings, the snap. Yeah, from this corner straight to up here to the shear wall. To wall. Yeah. So you can see that it's automatically insert the beam for you already. So again, as what I mentioned just now, if any insert of the new members, the slab will be deleted. So let us go back to this slab here and insert the slab back again. It's quite simple. All right. Okay, so we're done. So in this example here, we already done our retrofitting intervention and strengthening interventions. The wall, we apply FRP. This column C2, we apply FRP. C1 and C3, we apply concrete jacket. And the 2 beam, we jacketed the beam. All right. So if you want, we can even, let's say, if you want, we can even apply a concrete shear wall here. If you want to, we can try to apply that. But I think maybe let's do it in the next round. If let's say this structure is not passing, then we can apply a concrete shear wall. Let's exit from this model. As usual, it will ask you to save. You say yes. All right. So once we done everything, you move out from this, from our seismic building model interface. You can see that this column here is already looks slightly enlarged. You can see that because of the concrete jacket, similar to this column. This one is already applied with the FRP. Looks like its color is not very dark because I think the specific type of FRP that we chosen just now, and the shear wall, the concrete wall is already applied with the FRP wrap. Okay, so once we're doing that, let us go back to our same setting again. Concrete code requirements. These are 2 performance levels that we select earlier. Analysis, in this case, maybe to save some time, maybe I don't want to carry out all the full 8 cases. Because I notice is the more critical one is at the Y direction. So maybe unclick these 4 cases here, maybe saving our computational time by half. All right, and we keep the knowledge level the same, the seismic action the same as what we applied earlier to our existing building. The rest of the settings are the same. So once we go in that, we're happy with that, we go back to the eigenvalue analysis. As usual, it will ask you to save before you run the analysis. You click OK. Then we click analysis. It should be very fast. So done. So complete the eigenvalue analysis. Similarly, you can choose to have a look at your result if you want to. All right. So, but I'm not going to do that. I will go to the next step, which is the pushover analysis. So in pushover analysis, we run the analysis. So in this case, it's only run the 4 cases. Okay, start with analysis number 21. Maybe let's have a look at the real-time reform shape of the building. See any, say in this building here is Y direction. You can see that is this column more rigid now because of the strengthening of the effect of this complete jacket. And this beam is more stiffer as well because of the enlargement as well. Okay, second analysis. Okay, have a view of that in this other view as well to see how this column perform. And also this beam as well. This enlargement beam just now, this jacketed beam and jacketed beam here. Okay, analysis number 3, which is in Y direction, eccentricity negative Y, which is in toward the right hand side, not pushing in the other directions. And finally, the last analysis, 24, negative Y and negative eccentricity X. Because I always found it quite useful. You have a look at this view here, at least that you have identified the buildings, how it performs in this pushover analysis. Okay, so you've done all the 4 cases, come up with this message. You have reached the specified maximum displacement. Everything looks fine. If you want, you can go back to show the results, have a look at the results. Okay, so in this case here, maybe I don't want to, yeah, you can have a look at yourself. But most importantly, we want to go to check the number, see whether is it okay or not okay. Okay, so let's see the results. Oh, it looks like it's quite okay. Although there's some slightly, let's see the failed members. There's some slightly improvement, but it's still more than 1. Okay, in this particular wall here. So you need to try to play around with to consider other type of strengthening or retrofitting strategies. Let's go to the collapse preventions. Collapse prevention is better. Now, I think before that there's no failure as well. Let's see the all members, the columns at first floor only. They will be seen more clear. Can see that the ratio are reasonable. Now this one is quite low. Let's see the life safety. Yes, the wall are slightly, how to say, slightly exceeding 1. But you can see this column now dropped significantly because of this concrete jacket columns. Before that it was 0.81 something, now about 0.4 by half. All right. So although I think this column here will, in this exercise, we might need to think about to strengthening 2 more columns on both sides. or maybe the easiest way is you put, if the building, the structure allowed, you can put one concrete wall here. It will help you to strengthen the wall. Okay, let's go to the next one, which is the member shear forces. All right, and then we try to displace the beam only. I think just now because we noticed that the beam is failing. Yeah, now you see that the beam are not showing any failures. Maybe let me show you this one and all members. All right, so there's no sign of failure. That means these two beam looks like it's passed already. And collapse prevention, also same. And if you look into the beam, again, show only for the beam members in this floor here, you can see the ratio are now very, very low. So that means we already completely jacketed the beam values here. So now beam is okay, not failing in shear anymore. It works well. It's only this particular shear concrete wall that you might need to go back to think about other retrofitting strategies, intervention to improve the performance, or maybe put another concrete wall here in this direction. It will help to improve the performance of these elements. All right, so now we complete of this second stage. Now, if once you have done all your assessment, if you're happy with that, the next step, what you can do is, usually for any design office, you might need to print out a report for your client. So you can go to this this function here. We got a very powerful function of report generations. So you can see that is you can select what kind of information you want to put inside the reports. And then you can select to edit the text if you want to. If you don't like this writing, you can have your own writing. Then you can update the value, the text you want. And you can even update the view of your structures. Like in this case here, the 3D views. This drawing, it will put into the drawing, the report in this view. If you don't like this view, you can try to change other view. Maybe I will prefer this view will looks better. Okay, this view. All right, so I update the report view. You capture this view in your report already. You can even include like some of the member types, what type of member you want to put in. You want to put in horizontal, the vertical member, and so on. So you can decide from here. And the beam column join, all the elements. If you try to add in all, you notice that is you will increase the number of pages. So you can try to generate this report yourself. Usually it will be part of the index appendix. So if let's say by default the number of pages of the report is about 128. If you're happy with that, let's click OK. So it basically will generate a report behind for you. All right, so you capture all the image. All right. You capture all the results, all your drawings, your model, and also all the elements, your jacketed sections, your FRP details, and then you will start to exporting each of the members and creating the reports. All right. So beside for this report is seismic, we also got one function here, which is if you look at this function here, is to generate this button here, is to generate a report, generate the CAD drawings. That means we can export the CAD drawings. It's quite easy. You can click this button here. All right. Maybe let the report building do it behind. Method. All right, so we can export to the DWG drawings. Maybe let me finish up this report building first. It's already nearly 83%. All right, so it's done. Okay, this is the report, how we generate. So you can feel free to edit the text. You can decide what picture to put in, but by default, this is the setting of this report. Is quite useful. You also include all your performance levels, the report, the tables, all extract from the ASCE 41. So it's very, 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 very convenient. So you can go through this whole report. We're also including all the material models inside the report as well. Okay, all the calculations. But of course, I didn't include all the detailed calculation for all the elements. You can add that yourself. But this one is, without that, it's already 128 pages. Recently, I tried to include all, it cost nearly about 7,000 pages. So it's quite really a lot. All right, so we done this one. So we go to, maybe we can save this report. Now, let me close it first. All right, so let me continue to the export to the DWG drawings. DWG drawing is quite easy. You can export to level 1. You can create first floor or second floor, up to you. All the output is here. And what you need, I keep it everything by default. All right, then I just create. Then I will decide where to put the file. So I will create, save it in all the folders here. Under the trainings, webinars, CAD drawings. Maybe I will save it in the CAD drawing here. And then I just click create. Oh, there's some of the old file. Let me overwrite it. I say yes. All right. So it's straight away it will be overwrite it into the folders. Yes, this is the 2 file that I create just now. So if I click one of the files, so we can have a look at the CAD drawing that it generates. Okay, click continue. All right, so straight away it generates the drawings, the CAD drawing for you. What I'm going to show you is first thing you generate all the plan views, the drawing for you, including all your retrofit sections, the 2 columns, the jacketed column here, jacketed column, FRP columns, and also your some of the section detail here. You can see that some of the section detail like jacketed column, okay, and some of the jacketed beam section here is all here, all displayed from here. So it's quite convenient. You do that all for you, and including all the scheduling, the tabling for all your original column details, the jacketed column details, and also the jacketed beam details. Okay, so let me go back to this view. All right, so that's it for this exercise. So I already complete my 2 stages of seismic evaluations of these simple buildings. So this is the end of my webinar sections. If you got any questions, if you all want to rise out, you can feel free to use the chat room. Maybe you got any question, you can ask me in the chat room.